MicroAI is a leader in understanding lifecycle management of machines. The company leverages edge-native, tiny AI/ML firmware to provide predictive maintenance, improve operational efficiencies, and enable intrusion detection for connected edge and endpoint devices. This video will demonstrate MicroAI's innovative security approach to IT and OT edge and endpoint systems. Organizations across all industries build intelligence into virtually every new product offering and every industrial or manufacturing environment. From consumer electronics to automotive to building automation, advancements in connected edge and endpoint devices are paving the way for a new world of connected, smart systems. But with every connected innovation comes new security challenges. In particular, zero-day attacks that lead to ransomware is becoming a problem for consumers and corporations alike. Analysts believe the democratization of these attacks has already begun. MicroAI security addresses this new challenge with an innovative, embedded intrusion detection system that uses tiny AI firmware to identify anomalous security threats in real time across all connected edge and endpoint machines and devices. The purpose of this video is to demonstrate the capabilities and performances of MicroAI's intrusion detection. In this video, we will observe the steps in which a hacker conducts a zero-day attack and how MicroAI's unique approach is able to identify specific devices being targeted with malicious intent in real time. Security dashboards are available from MicroAI for some use cases, and for the purposes of this video demonstration, will be utilized to highlight real-time intrusion detection. Our white hat hacker will target a standard Raspberry Pi as the edge device for the purpose of this demonstration. MicroAI's embedded security AI firmware is within the Raspberry Pi and is the core to identifying the intrusion anomaly. We begin with the embedded MicroAI firmware displaying normal operation parameters of the Raspberry Pi. With this inferencing and continual learning of machine behavior underway, let's walk through each step of the zero-day attack and demonstrate how the solution is able to catch malicious attacks on connected devices. Step 1 of a zero-day attack is to gain access into an end user's network by finding weak points in the network configuration. This can be done in many ways, but for the purposes of this video, we can see a hacker leveraging credentials obtained from the dark web, which are IP addresses of the connected devices within the network itself. Here, the hacker scans the entire range of connected devices looking for open ports. Looking on the screen, we can see the results from their scan. Most of the ports on these connected devices are fortunately closed. However, the hacker was able to identify one machine, our Raspberry Pi, that has an open port. Next, the hacker will further explore our specific device to find the number of ports that could be open, which could be leveraged further to get into the network. As we can see, the hacker is running the IP address once more, and next, we'll see the results of that scan. And as we can see here, the hacker was able to identify 3 open ports on that specific device. Returning to the customized dashboards provided by MicroAI, we can visually observe in real time MicroAI's ability to catch the hacker's attempt to gain network access. First, there is a drop in the security health score, indicating the abnormal behavior by the detection of the anomaly of the hacker trying to gain access. We also see timestamp notifications and alerts, as well as changes in the behavioral matrix, CPU usage, and other system network metrics. Step 2 of a zero-day attack is when a hacker will try to establish a foothold by creating a backdoor. Here we see the hacker trying to do that once more, leveraging the victim's IP address and sending a malicious data hack payload to the port that will trigger specific actions. Once the payload is sent, the hack is able to set up a backdoor command. A backdoor essentially provides the hacker a fortified foundation to have solidified access to the targeted device. So once again, returning to the security dashboards of MicroAI, we can see a few different changes that signal that MicroAI was able to successfully catch the malicious abnormal behavior in real time. We see a drop in the security health score here in the top right corner, and timestamp notifications of the alerts of the anomaly. Furthermore, we once again see changes in the behavioral matrix, as well as the previously mentioned system metrics that are also listed. Step 3 of a zero-day attack is when a hacker will increase their reconnaissance or surveillance on the targeted endpoint device of the victim. The goal or intention is to latch onto the device by establishing a listening port. This is used to listen in on communications regarding the endpoint and will augment the hacker's abilities to later attack the device with the actual malicious attack. Once again, returning to the dashboard, we can see a few different things signaling MicroAI's successful identification of the third step of the zero-day attack. Here we see a drop in the security health score. We also see a timestamp notification in the bottom right corner, and we see changes in the behavioral matrix and the other system metrics as well. Returning to the hacker screen, we can observe step 4 of a zero-day attack, which is to escalate privileges. This, arguably, is the most dangerous aspect of a zero-day attack. It's when a hacker will actually try to start or download the malware before exiting the victim's network. Even before the actual planting of the malware, we can see the hacker trying to leverage various folder structures, which presents different attack options. Once again, MicroAI's dashboard catches the hacker taking the step. Hackers have different flavors and options of malware attacks. First, we can observe a memory attack, which is where a hacker will send a large amount of junk data that occupies the CPU usage of an endpoint device. And again, MicroAI catches the hacker taking the step. We see a drop in the security health score. We see timestamp alerts notifications. We see changes in the system metrics as well as the behavioral matrix. Second, another type of the malicious attacks that are growing in popularity are cryptojacking attacks. This is a scenario in which a hacker uses the victim's hardware to mine cryptocurrency. We can see the hacker trying to perform the attack. And once again, MicroAI can see in real time the hacker as they take this step with a drop in the security health score, timestamp alerts notifications, and changes in the system metrics as well as the behavioral matrix. Third, all too common attacks that have seen a sharp rise in incidents are ransomware attacks, where hackers take control of connected devices within the victim's network and hold them for ransom in exchange for decryption codes. Here we can see the hacker attempting to send and run the ransomware on the targeted devices. Ransomware attacks have caused catastrophic results across notable companies like Colonial and JBS, and any organization that contains connected or endpoint devices within their environment that are pertinent to operational success should be concerned. Here, once again, as the hacker is taking the step, we see a drop in the security health score. We see timestamp alerts notifications. We see changes in the system metrics and the behavioral matrix. The last step of a zero-day attack is mission accomplished. Once a hacker successfully plants the malware, they slip out the back door that was created and go into a holding phase. By the time the hacker actually turns the malware on, it's too late for the end user to do anything about it. With MicroAI's zero-day attack monitoring, organizations relying on connected devices can now see these attacks occurring and obtain the capability to prevent a successful malware operation within their compromised networks. MicroAI Security, an innovative approach to cybersecurity intrusion detection.